right, continuing on with our special cases. The last two, this one is going to be the sum of perfect cubes, and in just a minute I'll do another video where I do the difference of two cubes. The characteristics I've listed again, we're working with something that has two terms in it. Some of them are going to have a plus in the middle, some are going to have a minus in the middle. So right now we're working on the ones that are sums with the plus. The exponents on the variables this time are going to be in multiples of 3. So what are multiples of 3? Multiples of 3 are things like 3, 6, 9, 12, 15. I don't know why I'm putting all those commas. I don't really need them, do I? 18, and so forth. So you won't have any exponents that are 12s and 15s and 18s. Most of your exponents are going to be either 3s or 6s. And the coefficients on the lead term, in this case I'm seeing a 1, and the last term are going to be perfect cubes. So you've got to be careful with these. These are not perfect squares now anymore. They are perfect cubes. So there's the 1. There's the 27, which is a perfect cube, and then I see here an exponent that is a multiple of 3. So I know this is not a difference of two squares because I don't see a minus in the middle. It's not the sum of two squares, which would be prime, because 27 is not a perfect square and the exponent is not even. So that helps me realize this is a special case. You can see up here the formula that I'm going to be following to try to factor this thing, and I'll try to talk you through that as I work it. This one splits up into a binomial parentheses and a trinomial parentheses. So you can see that up here. We have a binomial parentheses and we have a trinomial parentheses. All right, so to get to the binomial parentheses, you're now going to take the cube root of the first term, which is going to be x. And you put that in the first position in the first parentheses. Then your I goes over to the cube root of this positive 27, and that's 3. This sign remains the same so that it matches what you start with. So since I'm starting with a plus in the middle on the original problem, I'm going to have a plus in the first parentheses, the binomial parentheses, in my answer. Okay, so once you get that established, then you work off of that to get this trinomial expression. So you take the first term here, you can see it right there, you square it. That brings me to x squared. When you get the middle term, this negative ab, what you're going to do is multiply these two terms together. How did that happen? I don't know how that happened. Hold on. There we go. Multiply these two terms together to get positive 3x. And then in the answer, you go with the opposite sign. So you notice how this sign up here is the opposite of what you see back there in the original starting amount and in that first binomial factor. And then to get the very last term, you take the last term, which in this case is the positive 3, and you square that. And that gives me positive 9. So there is my answer. And my students told me this semester I had never heard this before. This little thing to help them remember spelling out the word soap means that the first sign is going to be the same as what you start with here. The middle term is going to be the opposite. So you see a positive in this position, you see a negative in that position, and then the AP stands for always positive, on this last term. So I don't know if that will help you or not, but I'll try to say it for you a couple more times. Maybe that will help you remember this, because this one's pretty tricky and hard to get through. All right, so I'm recognizing two terms here. 64 is a perfect square. It's also a perfect cube. The cube root of 64 is 4. And the reason I know I need to be working with cube roots is I'm seeing that exponent 3 there, which is, of course, a multiple 3. I see the lead coefficient is 1. I can take the cube root of 1. So I think I'm going to go with my sum of two cubes. So small parentheses for the binomial, larger parentheses for the trinomial. All right, so here we go. The cube root of x cubed equals x. The cube root of 64, we just talked about that, equals 4. Since this started out as a sum, this first sign is going to be the same. So far, x plus 4 in the binomial parentheses. All right, so to get to the trinomial, you take this term x and you square it. To get the middle term, you multiply these two together to get positive 4x and use the opposite sign in here. And then you square, always positive, to get the last term out there. So there's our answer for factoring the sum of two cubes. Here, I wanted to do a couple more of these that get kind of messy. So let's quickly check characteristics. 8 is a perfect cube, 27 is a perfect cube. The exponents are both multiples of 3. I'm seeing just two terms in here, so this looks like the sum of two cubes. So smaller parentheses, larger parentheses. The cube root of 8 is 2. The cube root of x cubed is x. The cube root of 27 is 3. And the cube root of y cubed is y. I don't like the way these parentheses look. They got kind of crazy. There, that's a little bit better. And so I'm checking the sign now. Since this was a positive, a plus back here, I keep the sign the same. And then once I get that binomial established, I work from there to finish. So I take the 2x and I square it. I take the product of these two and use the opposite sign. And I take the last positive 3y and I square that. So you can see that SOAP, same, opposite, always positive on the signs there. And one more, because this one was kind of tricky, and I think there may be some like this in some of the homework examples. This one has a GCF. So the first thing you have to do on this is to pull out the 1/3. And let me briefly talk about how you do that. When you pull out a GCF, you take each term and divide it by the GCF. So you can see when I take the 1/3 x cubed and divide it by the GCF 1/3, I get a 1x cubed. The second part is a little more challenging. When I take 1/375 and divide it by 1/3, that's the same as 1/375 divided by 1/3 written horizontally, which is the same as 1/375 times the reciprocal or the multiplicative inverse, and you can see there how I get this 1 over 125. So now I'm noticing that these numbers in here, 1 is a perfect cube, 125 is a perfect cube, this exponent is a 3. So I'm thinking this is the sum of two cubes, but I have to hold on. Don't forget the 1/3, open up binomial and then larger trinomial. So the cube root of x cubed is x. The cube root of 1 over 125 is 1 over 5, because 5 times 5 times 5 is 125. Notice I kept the sign the same. And now I'm going to square the first term. I'm going to multiply the two together and use the opposite sign. And I'm going to square the last term. And we're done. So I hope that helps you with the sum of two cubes. I'll be back in just a minute with the difference of two cubes.